Hello, today we're going to explain AMC10, year 2005, question number 24. For each positive integer m is greater than 1, let Pm denote the greatest prime factor of m. For how many positive integers n is it true that both Pn equals the square root of n and p to m plus 48 is equal to the square root of m plus 48? So the function p means that you have to take the greatest prime factor of m. But in this case, the greatest prime factor of n is also the square root of n. So n is the square of a prime number. And this also means that m plus 8 is also the prime number for the same, m plus 48 is also a prime number, square of a prime number for the same reasons. So normally if you go from n squared to m plus 1 squared, you need to add n and then you add m plus 1. Which is definitely an odd number because this makes 2n plus 1. However, because it's 48, that means we have to do the process 2 times. For example, if we go from n to n plus 2 again, that means we get 2n plus 1 from here. We just carry it down, and then plus n plus 1, and then plus n plus 2. And in the end, we get 4 times n plus 1. So there's only one case, and that can only be 11, because if we go from 11 squared to 12 squared, then 12 is n plus 1. So that means 4 to the n plus 1 is equal to 48, which fits perfectly. And just to double check, 13 squared minus 11 squared is equal to 169 minus 121, which is equal to 48. So this works perfectly. So there's only one answer. The answer is B.